Right. So polygons, like that should not be a surprise to you that we're talking about topology. It's always a concern for a modeler to make sure that the topology matches the desired output. So you sort of tend to cater for whatever medium you're modeling for. And then also what sort of level of realism versus stylization and all that sort of stuff plays a role. With us, we even consider, distance from camera and, um, use of topology when it comes to level of detail. There's actually a built-in LOD manager component in Unity that also allows you to target it exactly that way. So, so not this project necessarily, but if we could just um, have a couple of example elements here. So for instance, this pug, I think there was a better version of this where it still had more elements to it. Okay, so if we took this character and just as an example did an LOD group on it, you would see that you can go and add different models at different levels of detail. So that's to accommodate for like larger scenes where you have detailed models at a certain level when you're really close to it. So like a first-person shooter, when you run up to a pickup or another enemy or something, then they'll be at 0 LOD, so the highest quality that they could possibly be. And then as they sort of move further away from you, they'd lose polygons, right? So we can either use this technique to reduce the polygons over time and just save out separate models for each, or you could simply like tag certain models as not being sort of relevant at lower levels. So at this stage, the list is empty, but you would typically say, okay, well, the dog body needs to be present at that level, and maybe I think the eyes are somewhere embedded there, but I'm just going to try and grab them and add them over there. I don't know why there's two of them now, but just as an example, you would have there, it actually shows you all the meshes that are going to display at this level, and then you can sort of cull out meshes that are like, let's say you've now built a belt or maybe some other details on the character that wouldn't need to display at a lower level. You can just cull them that way, but for most part you're working with the highest level possible. All right, because we're going to be fairly close to these objects when you exhibit them, right? So you can't really use the LOD component, but it's also interesting to know that Unity caters for different levels of detail. In the brief itself, we said that we're going to go through this polygon reduction process, but there's also things that obviously have a hand in this in the process, and things, underlying theories that you need to understand. So I've linked to Polycount, which is a wiki. It's sort of an age-old wiki on game techniques and technology, and it happens to be called Polycount. So this Polycount entry is about Polycount. If you just look at what a polygon is, this should all ring very or be very familiar to you. You work with them all the time. Maybe you see more triangles if you're more of a game student, because I don't know if you've ever bothered to go from shaded to wireframe mode. You'll see that everything is eventually triangulated in the viewport. So we're mostly concerned with triangle counts when it comes to polygon use, because that's what renders in the viewport in the end of the day. So another thing that I just quickly linked in our Canvas course is this Polycount rule of thumb spreadsheet. So if you go to Polygon budget, you'll see that there's a sort of a indication of where or how many polygons would be acceptable for a prop or an asset at a specific or targeting a specific platform or being a type of genre of game. And just remember that this is a rule of thumb. It doesn't mean that if you are making characters for mobile that you should be using 10,000 um, polygons. You would want to probably um, be a bit more smarter in the way that you approach it and try and cut down on model detail or topology detail whenever you can. You know, whatever can be translated into geometrical detail, that's better. I mean, textual detail is better. So just to give you an example of that, if you're working with something like, let me just revert these characters. Sorry, it looks like some messed up dog now because we've worked with it. Even here, it looks a little bit messed up. I've accidentally saved over the even more messed up version so I can show you what not to do. But just so you get an idea, this model is currently 51,000 triangles. Okay. I think that was all of it. This one specifically is only less than 7,000. So I'm just kind of curious. Oh, it's the entire scene, and there's other models and stuff. So okay, so it's not 50,000. I was just about to say that's a bit much for this model. But just something worth knowing is that if your Blender doesn't show you the scene statistics, you can just right-click and say scene stats. Then it'll show you the amount of triangles in the scene if just objects are selected. But if you're in edit mode, it actually shows you how many you've got selected now. So there, 6,000 tries. 6,000 tries is a fair amount of polygons for such a small character. It obviously has its limitations. You can see that, you already start seeing some edges and normals freaking out. But if the character is always only going to be displayed like at this size within your game, then that's totally fine. There's a couple of other things that you can do to try and make this model appear better in Unity. Like, for instance, going to the smoothing groups over here and perhaps either letting it auto smooth or setting a smoothing or crease value that supports your geometry. So I think somewhere around here where it's not entirely smooth, it's still better. What you could also do, though, and works really well for low poly models, if you're sort of building up something up from low poly. So let's assume that for argument's sake, I'm saying that the model is of a sufficient sort of poly count, but I want to go and add more detail to this and have it display better than what it does currently. Then I would go and add something like a multi-resolution modifier and subdivide that rather, because when I bake from this higher definition mesh, I'm going to bake normals that are better looking in general. And I can also go and sculpt on this now and add more sculptural detail and things. It doesn't make sense to try and paint normal maps because they don't really make sense in themselves. They don't seem like something that you can just look at and figure out. You need to know which direction the normals and the gradients are working, and then sometimes you get inverted normals based on whether you use, I don't know, Unreal or Unity or Metallic or Specular workflow. So yeah, painting normals really doesn't make sense. Okay, so yes, polygon budgets for, I think maximum for those at least. We're normally trying to hit sort of 15,000 polygons for our main hero characters, and no more than that. So yeah, this is just a rule of thumb. Maybe if you do want to reference that at some point. Text tools is something that I use in Blender for baking some of those maps. So like I said, if you wanted to bake the multi-res information down to the lower level model, for that tool to work in this case, you would actually need two meshes. So you would have to duplicate the mesh and then have the one multi-res and the other one not. And then you pick them both and then you bake it. But you could do the same thing. So all of that baking functionality is under the text tools underneath your UV map settings or UV editor. Some of them you can just bake from the mesh itself. So there's some useful ones for setting up material IDs. I'll show you how material IDs play a role later when you have like multiple objects in your on your model and you want to paint them different materials. Essentially, the reason why we're going about it this route is we want to maximize the amount of texture space we spend on the model, and that means including things that aren't necessarily part of the model. So or one mesh. So in this case we have a tongue and we have teeth and we have eyes, and well, we have a little bit of an environment, which I'm not too concerned with if that's a separate texture, because you know we're not always going to be using that same little plinth. But for the rest, you want it all to be on one texture so you can load it once and then that's it. So UV layout is also a really important thing to consider once you're working with a low poly model, right? So you won't be able to bake anything in any case if you don't have UVs on the underlying mesh. Right, so in this case it says it needs a high and a low version model. Interestingly enough though, if you consider it that you're baking the high detailed information from a mesh down to another mesh, or a texture rather, only the low poly model needs UVs. So you don't really need to keep your UVs intact when you're sculpting or anything like that. Only when you've retopologized does it need UVs. So there's another entirely different approach. Like if you didn't start with a low poly model, but you started with something that you generated or found somewhere else. Like if you just download a model from Sketchfab, right? Anywhere from Sketchfab really. I think I signed in here the other day and we grabbed one of these, or I couldn't sign in. Let me just go to Sketchfab directly. And I did actually download something already, so if that would save me some time. So we downloaded this backpack in two formats. The one is a standard GLTF, which is what Sketchfab uses. That's a WebGL format. And then the other one is in OBJ format, which was what the original was. So if I just go ahead and import that OBJ, or rather the GLTF, which is I guess the more common one, because that's what they're all going to be. File, import, GLTF, downloads, backpack, scene, import. Okay, so the scene is a bit higher than the floor, so that's just something you can just straighten these models again. But let's look at this model quick. So you can see that, and this happens quite often when you source models from other places, then they'll be triangulated, they'll be smoothed. And if we compare this to what the other model looks like, I think in this case at least it's textured, so it retains its materials. All right, and in the other format, the textures are separate, so you need to relink them. And I think you can say split by object or split by group, so if you want it into separate bits, then you can do that with an OBJ. Each format will give you a different sort of result and options in Blender in any case. So here the topology looks somewhat different. It's all quads. It's still a bit high poly, so this entire model is already 50,000 triangles, which is way beyond what it's supposed to be. And this one, I think they both should have their UVs intact and everything. So if I go to my UV editor, edit mode, you can see that this is a a well-made texture atlas. Everything is packed really nicely. It seems like everything is spending a good deal of space, of texture space on there. Let's look at the stretch display or area. Then you can sort of see where there is a little bit of stretching happening, but it doesn't seem to be too problematic, only in those bands. So if you would need to, let's say this is way too high poly, we now need to bring this poly count down. In this version, we could perhaps start by going and saying that the mesh faces need to be turned to quads. So that does help a bit. But you can also see from comparing this one to that one that this one doesn't really have any of those weird little cross-section polygons. So it tries its best to match the edge flow, but it doesn't always get it right, and then you end up with all these sort of skewly stitched edges. So that's not first prize. And you also need to keep an eye on whether or not it's actually messing with the textures, because that's something that might concern you if you're baking from a high poly textured version. Like this would be the case if we source this model from somewhere else. If we actually did a photo scan or something for this model, then we would sit with the same type of scenario where we have to reduce the polygons of this model to a point where it's actually usable in game engine. I did this little exercise that I wanted to show you as well with. So this is an app called Trinio. It's only for iOS as far as I could tell, but it's not the only one in the market. So it's the easiest one that I could find, and it uses ARKit, which is sort of a combination of your gyro information and your camera information, and it's constructing a sort of a point cloud out of all the little images and captures that it makes. So it can figure out afterwards what this geometry is that I've just scanned. This is quite a small model, so, and you can see my finger gets in the way every now and then. And that's just sort of one of the techniques. The AR technique is a more recent one. Apple released another update on this kit of theirs that is going to make it even better, because they've got sort of LiDAR integration and things like that now as well, and true depth cameras and whatnot. This is the more traditional version of photogrammetry. We would actually, even with a DSLR, go around and take pictures from different angles. So I did both techniques in this case. I used the LiDAR technique on a bigger object like a room. It didn't seem to work so well there for smaller things. The resolution isn't that high. But for scanning a room, it's quite cool. Or maybe a car or something bigger, like or a building, I guess. So both these methods then take a little while to process, and then once it's done, it sort of sends you a notification and then opens the. I did speed these videos up a bit. So this was the one where I just took photographs, right? So it could figure out that I wasn't actually aiming at the chessboard, and then I exported that as an OBJ. So that's quite convenient that you can just grab it from your phone like that. And then the other one, I also tried a dinosaur at some point, but the little fingers and things didn't pick up so well. And I'll show you another one that I did a year or two ago, just to show you how the tech has actually improved already. Okay, so this one was the one that I thought came out better in general. And I can also show you what that model looks like, just so you can compare. I mean, the OBJ and the MTL files that close together or in the same folder, they do tend to retain the textual information. So that's kind of cool. And then you can see I have a model. That's the geometry. It's not great. It's certainly not great if you start looking at the actual topology. But what it is, it's a really good capture of the of this thing's texture. So there might be something that you'd want to retain there. All of these methods listed over here, though, like all of these sort of shortcut methods to reduce the amount of polygons, from decimate to remesh, shrink wrap. Well, except for B surfaces and shrink wrap maybe. But these sort of auto reduction tools tend to completely destroy your UV layout. So if I wanted to have this model but with a lot less topology and still keep this, I wouldn't be able to just go and say, I don't know, something like decimate. Decimate tends to, well, it only works in object mode, or it'll only display what it's doing in object mode. So I'm just going to have to show you the wireframe on this model in any case. And then, so the lower this ratio, the more this model sort of starts breaking up. And if I now go and apply something like that, you'll see that the UVs are wrecked for most part. Okay, so they've now introduced all sorts of others, stretching issues and so on. It's not, this isn't even actually that bad. Like, it could have been so much worse. The unsubdivide one tends to be a little bit more systematic, so it's sort of across the board reduction in polygons, and on even iterations it doesn't do such a terrible job of reducing that. So there you can see this is now actually a really sort of good poly count for what this object is. It's now only 12,000 triangles, so it's within that, it's underneath that 15,000 max, and it doesn't look too bad. But I do think we may, if we apply this, introduce some other issues. Okay, so that, yeah, now the UVs have crossed over and they're linking across islands, because we may have eliminated some of the edges that were marked as seams. So that's quite terrible to try and clean up. It's really whether you want to clean this up or not, because you could just produce new UVs altogether and then just use the original to bake the textures back onto those, if that makes sense to you. So I would actually, instead of applying this decimate, first make a duplicate of it, so that you have a version with intact UVs, and then you could go and say, fix this one, let's not apply that one, just maybe hide it. And then later on when you bake, you have to be in cycles to bake. However, you can go to baking and you can say select it as active, so that allows you to select more than one object or bake from another object. But the low poly would need to be redone. Sometimes you're lucky like that, where it's just a matter of a subdivision that was applied that shouldn't have been, and you can reverse it. Other times you're stuck with topology like this that really wouldn't respond well to something like decimate or unsubdivide. There's nothing to unsubdivide. I would actually go about this in a way more traditional way if I used photogrammical data, something that I wanted to retain. So maybe it's the shape and maybe it's the texture, or maybe a bit of both. Sort of try and get this straightened out. I don't know why it's such a weird angle, but let's just make it so that this is its default. Then I would probably first of all get rid of everything that I don't need. So probably select a portion of this model and expand the selection until it grows into something sort of resembles the area of interest. Okay, so that's probably far enough. Alright, so now we have a lot less information to work with, and then I would go about it like in a more sort of traditional retopologizing kind of process, where I would sort of start matching the shape roughly. Maybe even start with a model with less iterations, because 32 is quite smooth. Sorry, I'm just trying to, where is my marker now? Hello? Ah. Okay, and then on top of that, use another tool called shrink wrap. Okay, so shrink wrap snaps your vertices to the nearest surface, so you have to give them a sort of a point of reference. So it's telling it to snap to that surface and maybe give it a little bit of an offset so it doesn't intersect so quickly. And then as it's doing this, I can continue to I also just want to see this in modeling mode, to expand or what is it, to extrude these edge loops along the surface of this model and try and match it to where the interest or the detail is, keeping in mind that it's going to try and do that as easily as possible. It's always with like sort of geometry and shapes. Its interpolation is always designed to go for the shortest possible route. So you're going to have to sort of compromise and say, okay, well, I'm obviously going to have to go and put in some more detail over there. Work with what the tool is going to do, and then you can go and fix it later. So in this case, I'm kind of happy with this as a result, and then I can go in and sculpt. I can also just go and apply this, and let's do some more editing here. But even in sculpt mode, if we can just see some wireframe here, you can just smooth out those edge loops a bit so that they're not as harsh, and they sort of find their own space and make more sense. And there where it didn't quite snap, there where it didn't quite snap to the surface, you can go and add maybe a few more edge loops there. So see what that does. Back and forth you'll go, repeat the process of adding a shrink wrap, telling it to snap to that surface, and then even with the shrink wrap modifier on it, you could use something like the thumb sculpt mode, just so that you can slide these curves for where, to wherever they should snap to, rather than where they are snapping to. That's going to take some more modeling and refining, and then once that's done, you would typically go and unwrap this model. So in this case, I'm just going to be lazy about it and say unwrap it as a cylinder. I'm quite curious, sometimes it gets the angle of the cylinder wrong, and then you have to set it to a different angle, so it's worth checking. Yeah, that's okay. You can set the alignment over there if it's not in the right place. And then you would say, okay, well, now that I've got UVs on this model, I just need to bake whatever textural information I had over there onto this new texture, onto this new model. So I'd go and create a new mesh, a new texture. Just apply this as well in any case. And that texture would need to be applied to material on this object for it to be able to bake to it. So I'm going to have to go into my shader editor as well here. This process is a little bit painful. You have to then go and get an image texture node, plug that in. I don't even know if it needs to be plugged in, but just make sure that you're baking to the right texture that you actually have there. And then in the baking process, you're just, again, going to have to be in cycles, and you're going to have to tell which model is actually the selected or the active one. And you can also choose what you're baking. For now, I think, let me try bake something that's a little bit more obvious, like the ambient occlusion. Although we're actually more interested in the diffuse. So select that one and then that one. I think that's the right way around, and if I'm wrong, then I would just swap my selection and then bake it. But okay, so here we're baking textures. We should see an update over here. It's not real time, so I'm still waiting for that to finish. And there you can sort of see how that other texture, if I hide this now, is applied to this. Now this shader obviously has its own set of issues here, like what even is happening here in the display. Is it displaying the texture? That's whack. It even it saw those as transparent areas. So you can change the extrusion and the ray distance and things like that if stuff like that is happening. You can also do this baking in Substance. Okay, so it also allows you to bake higher density detail to lower poly models. Substance did go through a bit of a metamorphosis again with their move to Adobe. So the way that I got around that, I think last week I was struggling to show you that, yeah, so it would be in last week's notes. There's a download button for Adobe Substance where you can apply for the license, and then there's also Quixel for Unreal, which is sort of similar. We're probably going to be using examples in both of these throughout. It makes more sense for us to go with something that's free rather than always be sort of locked down by, you know, Adobe tax. So we try and avoid that. But as far as industry standards go, I think Adobe's probably a little bit ahead of the curve with that. And Quixel still has to catch up a bit. So we're probably going to use Painter for most of our examples. So in Substance Painter, when you're baking out the mesh maps, as I'd like to call them, or as they're called, but I like referring to mesh maps because it gives you an idea of where those textures are actually originating from. So something like normals or ID maps or curvature or ambient occlusion maps are normally based on you know, the mesh information. So you can go, this is what that pug looked like if you just unwrapped it in Substance. So that's its auto unwrap feature. It's not great because we don't have an awful lot of resolution in the face, which is probably the thing that we're going to be seeing the most. And it seems to get a little bit more dense here towards the end, so it's a bit of a skewed or warped UV. I would have done that a bit different. So yeah, if you say bake mesh maps, you can bake all those normals and things from a high definition map if you simply go in, or high definition mesh if you've simply exported the two variations of your mesh. Otherwise, you can also just bake these textures as is. There would still be some value for you in those textures. So if I just go textures that are in the project now, then you can see that the ambient occlusion or the thickness and those maps are available there for you to export if you're going to use it as on top of your texture baking or texture painting process. You can do that. Or like I said, through this tool is also an option. All right. Okay, so I used a little bit of shrink wrapping. B surfaces is something that is more in line with, I mean, it uses a combination of the sort of shrink wrap approach along with another tool that comes with Blender. If you go to, and maybe that would have been a better approach in this case. Did I? Okay. Right. So if we go and to our preferences and check out add-ons for B surfaces, then you'll see that mine's already activated, but it comes with Blender standard, and it's under your mesh tab category. So I think in your 3D viewport, you'll have mesh, and then you'll have B surfaces there as an option. So what we could do with B surfaces is you have to sort of, and again, this is a tool that has a lot of functionality similar to this one. Remember, I linked that in the class notes as well, so you can go and check out what that tool is capable of. This is free, and it has a lot of functionality, and you might not use it all that often in the beginning, but obviously, you know, having it enabled and having some of this functionality might come in handy down the line. I don't use all of it. I mainly use it for baking material IDs and the occasional UV trick. But do check out this page if you're interested in any of these sort of tools. You can see that some of them are quite elaborate. Yeah, you can even generate some patterns and stuff with it. Okay, so in B surfaces, it also has some documentation that you can go and have a look at. So I'm just gonna, I think, like wing it as best as I can remember. So initialize a B surface, and then I need to draw on top of this. So maybe just switch this to matcap material and not have wireframe on top of it, so we can actually see what's going on. And then I would go and draw some lines on and around this surface, perhaps. And you can see it sort of follows the contour. So that's cool. I'm not sure how well spaced my lines are at the moment, but once you think you're done and happy with the marks, you can also go and add to you know, it would have made more sense to just do a third or whatever, or a quarter of this shape and then just mirror it, but okay, let's just go with this for now. And then you can go ahead and say add surface. You just need to keep in mind following the contour, only 1 crosses 5 seems okay, maybe more. Sort of trial and error again. Add surface. So there it's gone and added a surface. Isolate that and see. Okay, well, we obviously need more intersections, and we needed to close automatic join. Yeah, we weren't close enough, I think, for that, but that did create a surface. If we maybe just go a step back and bump this up quite considerably and then add the surface, maybe we get slightly better results. But also there's nothing stopping you from then going and tweaking that shrink wrap process. Maybe better, maybe not. Maybe not the right kind of shape, maybe not a very good example, but there's a tool that you could use to retopologize. And it works well for faces, especially if you're in tune with where edge loops and things need to go on faces in general. Okay, the other polycount link that I added was to the texture atlases. So that's again just a reference for you know, seeing how texture atlases are generally produced and used, and in terms of optimization, and there's a bunch of resources if that's something that you're really interested in. There's a bunch of packing tools and things that other people also use, like that one that I just showed you in Blender, the text tools one, and Substance sort of doing a bunch of that blending for you. I mean baking for you, but also generating the UVs, so helping in that packing process. And again, there's nothing stopping you from bringing a model into Substance, doing a portion of the unwrapping, and then taking it back to Blender and you know, breaking it apart and finessing it a bit. Whatever gets you to the final output. So we were talking about texture packing a little bit earlier when we were working on this dog, and then I mentioned that, okay, well, you know, it would make sense to have all of its textures on a single map. It's easier to paint in general. Your texture quality is driven by the types of textures or the images that you bake out from the various sources in any case. So you don't need multiple shaders, and you also don't need to do any shader setup in Blender for that matter, because all of the shader properties are different in Unity. For instance, if we just had a quick look at a model like this, where is it now? I think I hit it. Like this one in Unity wouldn't even display like this typically. So if you had this in Unity and you didn't have, let me just make sure that I'm on the right surface here. The right object, viewport display. I think it's actually in material display. Backface culling. Backface culling is something that happens to meshes by default in Unity, and you can switch it off. You can go into the shader script and then go and, I guess I can just do that over here just to show you your universal lit shader graph has the option to switch your graph to either have it as double-sided or not. And if you saw something similar in your standard shader, or if you wanted to have something similar done in your standard shader, you would need to go to its debug properties. Obviously also it needs to be a writable material, and then you actually need to say that it's double-sided. But it doesn't work so well because double-sided materials generally don't take into the lighting or take the lighting into account from both sides. So if it's lit from the outside, it'll be lit on the inside as well, and that's why you need to close your models wherever possible. So don't leave cavities and things unchecked. I think this dog actually has a inside of his mouth built, but I don't think you're going to see into his brain. So you don't need to make cavities, and sometimes people even try and save more geometry space by deleting the back of the eyeballs. So you can do things like that, but just make sure that wherever it needs to be closed, that it's closed, because the shader and surfaces aren't going to hold up. So in this case, let's say, did I unwrap this? Doesn't look like it. Okay, so I'm going to go ahead and do like some whack projection here, like just smart UV, and it's never as smart as it thinks it is, because this just creates an awful lot of seams. But if we were going to unwrap the entire character and put it all on one UV set, then we would need to go and at least set up some initial projections. So in this case I would go and say maybe spherical projection, and then on that one the same, and then once those elements are unwrapped and they don't stretch, then I'd go into edit mode with all of them selected, and I'd actually go and pack these UVs properly. So then make sure that they are average island scale. So what this does is it scales everything so that it matches its scale in 3D space as best as it can, which is kind of like what you want. You may want to prioritize certain things later on, but for now let's just try and keep it accurate. And we've done that. You should have actually seen a reduction in the amount of stretching, at least the area stretching, so if you kept an eye on that. But then the other thing that you want to do is also just pack all of these islands onto your image. So then you can auto pack it, but again, it's not particularly clever. It still makes some mistakes, and you could probably do better, like maybe overlap the two eyes, not have so many seams in there. The right way of doing an unwrap on this dog would be to go and identify the edge loops that are the least visible. So maybe those around the folds of the neck. You can maybe cut a seam up the back of the head as well, maybe down the belly, And then once all those seams are identified, you mark them as seam, and then you just go into edit mode and actually unwrap this. So if I unwrap that now, so you can see the head is getting a little bit better now. I've got some idea of what it looks like. There's probably way too much real estate spent on the neck flab area, so I can make a few more cuts in there, so that most of my texture real estate is over here. I personally also like to straighten these, because I end up going and painting them in Photoshop and things like that eventually in any case. So I try and have it as user-friendly as possible. Obviously it needs to be all on the texture. And then another thing that I would do, if I'm going to be using this in any other painting application like Photoshop or even Substance, I also just make a copy of the actual UV stamp. So I export the UV layout as a PNG, so that I have that as something that I can overlay onto my Photoshop document. So, and it's also something that you actually need to submit as part of your texture sheet, so it's useful to have. I'm sorry, I think I was busy doing something there. Yeah, so when you start bringing in your other textures and stuff, they can just function underneath those UVs. I would normally put it on something like multiply, or depending on what it's doing sometimes, or depending on what the background color is. If it's a light color, then I keep them dark, and if it's a dark color, then I invert the UV stamp and just have it there as reference. So you don't have to, you obviously don't paint directly onto this texture. You'll assemble your textures from underneath. And you might want to start like with this, just sort of base colors, and then overlay a sort of a fur texture. You can also go and find some textures in something like Substance Alchemist, or that comes with some samples now. It's like once you start texturing, of course, first you need proper UVs, but like once you start texturing, you can go and look for substance sources. There's hundreds of different materials, but let's say if there's something like a that's just a ceramic tile, some tweed or something, that's fabrics, and I'm sure there's slate. I'm sure you'll find like a hair or something as well. For now, I'm just going to use like tweed. Apply that, and then go and you can change parameters over here until you get a better result, and export textures. Or if you've painted it, so if you've painted like let's say not necessarily paint, because I've painted with a smart material now, which what it does is that's not what I meant to do. Give me back my viewport, please. Say smart materials, search hair, facial hair. It's not what I wanted either. I mean, it might work a little bit down here and then not in other places, but that's part of the texture painting process in any case, so don't want to get into that yet. Just need to make sure that whenever you paint textures, or whether you're using photographic textures, it makes a bit of a difference. Like if you're just painting in 3D, then this UV set is perfectly fine, because you're just painting on the surface. But if you're ever going to go back to Photoshop, it becomes a lot more difficult. Like if you need if you needed this to have like a sign or a stamp or something that said, that had some text on it that couldn't stretch or something like that, if it was a robotic or more robotic looking element, then these UVs aren't great. Then you'd need them to be more structured and aligned. So it does depend on what methodology you're following as well. All right, so let me just close week 1. It's getting confusing. Okay, so in terms of model preparation for Unity, we need to keep in mind that yes, we can auto UV unwrap in something like Substance. UV Atlas is important, but what happens to like modifiers, armatures, that sort of stuff? So the example that I used before was a version of this dog that had a mirror modifier that was still active. So with mirror modifiers, the problem is they won't give you unique UVs for the parts of the mesh that doesn't exist yet. And with subdivision modifiers and things like that, they actually bump up the poly count, right? That's obvious. So you need to make sure that when you finally export this as an FBX, that you don't have these. You don't need to delete the modifiers. If you simply disable them, they won't bake. Because what happens in the process of taking a model to Unity is you end up triggering. Well, if you just take a blend file, you end up triggering a automated conversion process, which takes the blend file, figures out what was visible, what isn't, what does it think that you want out of that blend file, converts it into an FBX based on those parameters, and then gives you what you have, what you see in Unity. So it doesn't mean that this is the native blend file, even though it sort of responds like that. It has actually gone through a process of interpretation. So you need to also kind of be aware of that process happening because of what it does to modifiers and rigs and weights and shapes and normals. By default, you have a set of parameters that you can go and change when you export an FBX. Okay, so there's the option to embed the textures. There's the option to only export the selected objects or certain components from that. Whether you want to save everything as or scale everything as an FBX sort of scale, which does help because it zeroes out all your transforms and things that you might have in Unity, so you don't have to rotate your Blender files constantly. It automatically by default includes the normals or the face values and tangent spaces and those sort of things. Applying modifiers on by default. You can go and set all of these things if they cause you issues, but at least then you're in control. Whereas with Blender, if you actually go, or blend files, you actually go and look at, you have to go dig a little bit and it'll be different for everyone. But in my case, it'll be like in my library folder, under Unity, under, actually I don't even think it's here, I think it's in the application. There's a little Python script that dictates the settings for the Blender interpretation. So where's it? There's Unity, and then that version of, and that's another thing, is that it changes for every well, it doesn't entirely change, but in some cases it changes from version to version. So I actually have to go and explore my package content, and then in plugin API or scripts, I think it's plugin API, no, it's tools, yes, it's under tools. There's a Python script for FBX Maya export, and then there's Modo to Unity, and there's the Blender to Unity FBX Python script that runs and converts. And you can go and update that and save it and then change the way that Unity does it by default. But here you can actually see what it's doing. It's checking existing as false, use selected as false, so it's going to bring in everything. It does bake your modifiers by default. It doesn't smooth the mesh. So if you don't set your normals, then they're going to be hard normals. They're not going to be smooth. In other words, things look like that. Okay. Unless you're doing low poly modeling or low poly model assets where you like the faceted look, this is probably not what you want. So you'll need to go for a smooth shade, and like I said earlier, you can go into your normal options and still go and tweak this, There's even some add-ons that you can install for Blender that allows you to, I think here they just show you face orientation, and I think you can do some overlays where they actually show you the normals poking out, in which direction they're showing, or they're facing, but you can't really do much with that information other than those other parameters I showed you. There are some tools though that allow you to actually grab that little normal angle that's sticking out and rotate it so that you can tweak it like that. The workaround though is to bake it out, or just make sure that you set it properly in here, because whatever you set, whatever smoothing angle you set in here, that's what's going to be in Unity. The one thing that I have a problem with, that I wish was different in its default import, is this. It's actually taken out, and it's not listed here. And you can add it. You know, if you know what it's called in Blender, you can just add it as an option. But the one that I'm referring to is this. Only deform bones, and it seems to have not, it doesn't translate that well anymore. But just to give you an idea, this model of the pug that's in Blender format with all the widgets, so in other words, it's not just the deform rig, it's all the little components that come with the rig, is about 8 megs in size, so it's like a 9 meg file. And then this version that looks exactly the same, still functions entirely with its rig and everything intact, is like half a meg, or 800 kilobytes. So there's a massive difference in just optimizing your working file, and just actually exporting it and making sure that nothing that you don't need comes to Unity. And it might not play a role for a single model, but like if you have an army of pugs that's going to have to be on screen at the same time, it will definitely matter that you optimize that. Okay. There is an auto normals feature in the import settings of the model. So if you find the original file, you can go to the model section and tell it to, instead of importing the normals, to calculate it. And I don't know if you're really going to see a difference here. So that's what it looked like before. Is that the blend file? That is the blend file. So let's just go into, give me a moment here, please. Okay, so that's what it looked like before, and then if we don't calculate it, I doubt that we're going to see much of a difference. Might see a little bit here on the feet because of the fact that it was entirely smoothed. So just applied it, and it's having a fit. Oh, it's thinking about it. All right, so it has to go through that entire process again. Did it apply it now? I guess it did. I didn't see much of a difference, but yeah, probably just because yeah, there's not much there to work with. Might be a slightly less faceted, like around the brow area. You can see the difference between that edge over there and that edge over there. So it's a little bit smoother. What this import process, and also if you export an FBX, doesn't get rid of, and it might be a fun way of animating things, is shapes. So your meshes that had shapes on them would still have shape parameters that you can animate. Sorry, I just have two models on top of each other, which is also probably causing us not to see the actual changes we're making. But yeah, you've got access to shapes, so that's cool. Later on we're going to look at vertex displacement using shaders, so then we can you know, animate certain things in our scene without technically animating them, just sort of using different parameters. And then yeah, I think we're, if everyone's on board with, you know, what good poly structure looks like and what good UVs look like, then we're basically going into the texture baking process. Texture baking, like I said, can be done in a number of other applications, like Substance Painter, or you can extract different types of maps from one texture map. So there was this one example that I used in the other class. So if we just wanted to bake that information down as sculptural information, then I could go switch to cycles, again through that process of grabbing the shader and adding material. So unfortunately you do need these things to be in place. New material, and then in shader editor. Sorry, I didn't mean texture coordinates, I meant texture image. That's also not what I wanted. You can obviously bake to a higher resolution here if you want to. For now, I'm just going to keep it as an alpha. 32-bit float you would probably use if you rendered an HDRI from Blender, but for now we just want to capture this. So I'm going to go to that, and on my bake settings I'm going to say bake from multi-res, and just use the normals for now, and go ahead and bake that. Oh, one thing that you need to keep in mind is that it's trying to bake it from the highest level of the multi-res. So for the most effective use of this, you switch the viewport down to level 0 and then bake, because that's the furthest distance from the lowest level to the highest level. And now I can actually see the normals appear there. Okay, so I can go and apply them here again in Blender, but like I said, shader setup in Blender doesn't really make sense. But let's rather see if we can now sort of use a combination of techniques. So if I have my sculptural details, but I also want to have textural details, in this case something like let's see, like the snow covered, so maybe it's a snowman that I was building. Okay, so snow covered PBR shader. Okay, well now it's snow on tweed. Let me just see what I've done with my layers here. I don't want this one, please. Please, man. Okay, I'm gonna drag another texture underneath that, like base material, yes. And put the base material under the snow, and then I should be able to get rid of Mr. Tweed here. Okay. Alright, so maybe it's this kind of texture that I'm looking for. Not really the color. Like that base color, I would say should probably also be like white or whatever. Maybe that's the look that I'm looking for. Then I can go ahead and export these materials as well to use as a sort of a base for painting on, or whatever. Maybe I could import this as a texture that I'm going to paint with. Could do that too in Substance Painter, but for now I'm just going to use the normals just to show you what's happening here. You can have a preset output, so Unity Specular is the one that we're using, and I'm just going to say this is my snow normal. Okay, and then I think you can also go and set the resolution and everything of that. But what I actually want to show you is that if we want to combine the textual information from the texture and from the sculpt, we can do so in Photoshop. So if I'm going to grab that snow normal, and I'm going to grab the image that I created here, save as, also just drop it on my desktop for now. That's my sculpt. to combine those two, you simply overlay them and then save them out again. So an overlay, you get the best of both. So now I'll basically have a snowman with those indentations.